Hello everyone, I hope you're doing well. In this video, we're going to be looking at how do you factor trinomials and a couple binomials using some techniques that you learned in grade 10. I found this question on the McGraw-Hill-Ryerson Functions 11 textbook, Chapter 1, Prerequisite Skills, Question 7. If you want private tutoring from me, or you want to enroll in my grade 11 functions course, visit my website, tutor.ca. Okay, so this question has 6 parts. Each one just says factor completely. So let's start with this first part. Remember, factor means break up into multiplication. I want to break this quadratic, this trinomial here, up into two things being multiplied together. In the last video, we looked at foiling, which is kind of the reverse process. We started with two things multiplying together, and we ended up with this. But this is the reverse process. We want to turn this into two things multiplying together, like turning 6 into 2 times 3. This is factoring. Okay, so the way we do this is we identify what kind of polynomial we're looking at. So this is a simple trinomial. Okay, I know this because it is a trinomial, first of all, right? 3 terms. Okay? And simple means that what's called the leading coefficient is 1. Kind of just a fancy word for the number multiplying x squared, right? That is just 1. Okay, so it's 1x squared here. Not 5x squared, right? It's 1x squared. So in that case, we can do simple trinomial factoring. And what that entails is you look for two numbers which add to the middle number, 2, but multiply to negative 15. The last number. So we got to find those numbers. I like to start with the multiplication. How do you make 15? Well, 3 times 5 is 15. And yeah, I can make 2 out of that somehow. 5 minus 3 is 2. So 5 plus negative 3 is 2. And 5 times negative 3 is negative 15. So from here, I just use this information. To write it in factored form. So that's going to be something like x plus 5, x minus 3. Right? Simple factoring lets us just use these numbers that I just found here and just write it in factored form. That's it for part A. Part B, similar process. Part B, we have x squared plus 6x plus 9. X squared plus 6x plus 9. So once again, this is a simple trinomial for the same reasoning as above here. 3 terms, and the leading coefficient is 1x squared. So at this point, I'm going to look for two numbers which add to 6, but multiply to 9. And those numbers would be 3 and 3. Once again, I'm just going to use this information to write this in factored form. X plus 3, which I can actually write as x plus 3 squared. We call this a perfect square trinomial because it factors to a perfect square. Part C. Part C is 9n squared minus 25. Whenever you have a binomial like this, you certainly can't use simple trinomial factoring like we've been doing in the other examples. So what we need to do is we need to think about another method. And that method is a difference of squares. Difference of squares formula tells us that a squared minus b squared is equal to a plus b, a minus b. But you can really just think of it like we have something squared, right, minus some other thing squared, right? Maybe let's be clear that the square is not part of it, right? And that is equal to these two things multiplied together. The first thing plus the second thing. Okay. And then the first thing minus the second thing. So minus the second thing. Now, of course, the letters mean the same thing, but I think the letters make you think that it has to be just a single number, right? So it's really just anything squared minus something squared. So we can write this as that. It's almost that, because 9 is 3 squared, n squared. The n squared just stayed. And 25 is 5 squared. So we're pretty close. But I don't want something squared times something squared minus something squared. I want just something squared here. And what I do is I take that square and pull it out. So it's 3n all squared. And notice this 2 would then distribute back in, and I would go back up here if I wanted to. But I don't. I want to write it like this. And now I have it written as a difference of squares. And so I am ready to use the formula, which is going to tell me this is 3n plus 5, 3n minus 5. So a plus b, a minus b. A is 3n, b is 5. And it's factored. Okay, that's it for that. Let's move on to part D. Part D is write this here, right? Part D, we have a trinomial. But this is not a simple trinomial. This is a complex trinomial. Right? Complex trinomial. Right? The reason I know this is because it has 3 terms. That's what makes it a trinomial. Right? But the leading coefficient is not 1. It's negative 1. Doesn't count though. So what you want to do is you want to common factor out the leading coefficient, if that's possible. Okay? If the leading coefficient is not 1, you want to try to common factor it out if you can. And you can in this case, right? Common factoring out a negative 1, right? That's like dividing everything by negative 1 and multiplying by negative 1 to compensate, right? So what we're left with is negative 1 times negative x squared over negative 1. The point was that that turns into just x squared. Negative x over negative 1 is just plus x. And 12 over negative 1 is just negative 12. But really, you can just think of it like we've just flipped the sign on everything. And we've moved that negative to the front there. And now this can be factored as a simple trinomial. This is a simple trinomial. So once again, we want to find 2 numbers, which this time add to 1. It's 1x here. But multiply to negative 12. I like to start with multiplication first. I know that 3 times 4 is 12. And negative 3 times 4 is negative 12. And 4 minus 3 is 1. So this looks like the answer. Negative 3 and 4, negative 3 and 4. And once again, I can use this information, remembering that we have a negative in the front. Then inside the bracket, I would have x minus 3, x plus 4. And at this point, we're done. Remember, there's a negative in the front. That negative didn't go anywhere. But at this point, we are done. Okay. That's part D. Part E. We are again given a complex trinomial, right? Because it's a trinomial, but the leading coefficient is not 1. But again, we can common factor out the leading coefficient, the number 3. And we do that by dividing everything by 3 and multiplying by 3 to compensate. So we're just left with 3 times t squared. 3 over 3 is 1. 6 over 3 is 2, so 2t plus 1. 3 over 3 is 1. Once again, this is a simple trinomial, right? This is simple. And we can factor this as a simple trinomial. Looking for 2 numbers which add to 2, but multiply to 1. And this one's not too hard, 1 and 1. Okay, so we're going to use this information now to write this as factored form. So the 3's in the front didn't go anywhere, and then we just have t plus 1, t plus 1. Okay, and you can just think of that as 3t plus 1 squared. And remember, these 1's are what's getting us these values down there. Okay, that's it for part E. Part F is a very similar situation. We are given a complex trinomial. Again, this is a complex trinomial. But we don't have to do complex trinomial factoring on it because I can factor out a -5, the leading coefficient, by dividing everything by -5, right? But multiplying by -5 to compensate. So I just have -5, and then I just have x squared, -5 over -5 is 1. 40 over -5, right? 40 over -5 is going to be, well, first of all, a negative number. That's for certain, right? And then from there, you just actually need to divide 40 by 5. And I don't want to make a mistake, so I'm just going to make sure that I get it right. Yes, it's going to be 8. So -8x, right? And then -80 divided by -5 is going to be a positive number, right? It's going to be positive 16. And at this point, again, you can factor the middle bit here as a simple trinomial. So this is simple. And so we factor this by finding two numbers which add to -8, but multiply to 16. And those numbers are -4 and -4. So remember, two negatives multiply to become a positive, and two negatives add to become a negative. So we have -5, x minus 4, x minus 4, and you can write this as -5, x minus 4 squared. Okay, I think that's the last part of the question. There we go. So that's all for this. I hope it was helpful. If you want private tutoring from me, or you want to enroll in my grade 11 functions course, visit my website, tutor.ca. Thank you so much for watching, and have a nice day.